To construct a Venn diagram to classify rational numbers, first thing we need to do is we need to create our groupings. The first grouping is our whole numbers. Now, our whole numbers are going to be our smallest set of numbers. So we will grab our whole number title and we will drag it down here and let go and it'll click into place. So these are our whole numbers. Whole numbers consist of all the natural numbers, 1, 2, 3, and so on, plus 0. Anything that is a whole number and positive or 0 will fit into the whole number category. Whole number being not a decimal, not a fraction. All right, in the next one, we have our integers. So we will bring our integers down, we will release it, it will attach to the circle, and these will be our integers. Now, integers, as you can see, the whole numbers fit into this circle. So the integers are all whole numbers, plus the negatives. So all whole numbers plus the negatives, so 0, 1, 2, 3, and now we have, coming from the negative side, any whole number that is also negative. So -3, -2, -1, etc. All right, and then finally we have our rational numbers. And this one, you're just going to come up here, you're going to click it into place, it'll latch on or lock into place there, and these are our rationals. Rational numbers are exactly what they say they are going to be. They are ratios. So rational numbers have the word ratio right in their name. Any number that can be turned into a fraction. So there's a couple things going on here. It has to be a repeating decimal such as 0.3 repeating, because we can turn that into a fraction or a ratio of two numbers such as 1 to 3. Any perfect square that is in a square root symbol or a radical symbol, such as the square root of 4, that also can be turned into, the square root of 4 is 2, and we can put any whole number over a 1. So any perfect square inside of a square root or radical symbol can be a rational. Terminating decimals, decimals that actually end, 0.12, for example, we can place that over a 1, making it rational, and then we can multiply numerator and denominator, in this case, by 100, thus moving the decimal place twice. So this would give us 12 100ths. Again, we find ourselves with a ratio of two numbers. And then, of course, anything that you would recognize just as a standard fraction, such as 2/3, 1/2, 4/5, any fraction that you recognize. The last piece of the rational puzzle is that these can also be their negatives. So positive or negative, rationals, positive or negative, both will work as long as the answer or the number that you're working with can be turned into a ratio or fraction.